We're in a Providence home just before drywall, and this is a textbook example of how you should build a quality home. First of all, it's met all of its EPA Indoor Air Quality Plus and its Energy Star certifications, as well as its home energy rating. So let's take a look at some of the things that make this home special compared to the way typical homes are built in America. First of all, you'll notice that these studs here are 24 inches on center. We call that advanced framing. And so they cut a lot of the unnecessary lumber out of the house. That's because the R value of a 2x4 is only a little more than 4, where the R value of this bat is R21. So the less framing we have, the better, more energy efficient the home is. And homes are overframed. We really don't need all that framing. Another thing you'll notice that all the insulation is perfectly installed. There's no cracks, no gaps. It completely, it touches all 6 sides. It touches the sheathing. It touches the studs. It'll come in contact with the drywall. So we don't have any air infiltration or any gaps in the insulation. Another thing you'll notice is that they've air sealed every joint and crack. And that means that like here along the plate lines, and then they test this with a blower door to make sure that the house doesn't leak. Another thing they add here, they have Tyvek house wrap, which is your air and water barrier, as well as your exterior infiltration barrier. You also notice that they've used low expansion foam around all the windows and doors because that really reduces air infiltration. Now, another thing you'll notice if you take a look at the ductwork, all the ductwork is sealed and tested. So in other words, there's no gaps or cracks. Typical ductwork can be up to 30% leakage. Here, it's almost 0. Another feature that I think is important to note in these homes is the unvented attic. Notice we call this, sometimes it's called a conditioned attic. If you look up, the spray foam is on the bottom of the roof deck here. And that makes all your ductwork in conditioned space. That means that your home is going to be a lot more comfortable, a lot more energy efficient, and this attic is going to be within 5 degrees of the temperature of the home. All these things go a long way to making the home not only have good indoor air quality, but also be durable and long-lasting, comfortable and healthy, and energy efficient to live in. My name is Steve Easley, and I'm a construction consultant that specializes in helping builders build homes that are durable and long-lasting, energy efficient and comfortable, and healthy and safe to live in. I'm here in Jacksonville, Florida with Providence Homes, and we're going to be producing a series of videos that help you, the consumer, see the construction practices they use that truly are a step ahead of all their competition. In this series of videos, we'll be learning about things like the home energy rating score. We'll be learning about the Energy Star 100% certified rating checklist, which include the thermal bypass checklist. That checklist really ensures that the insulation is going to be installed right, that there's not a lot of air leaks in the home or air infiltration. We'll also be learning about the HVAC checklist, which is a big part of the Energy Star program. This checklist helps us ensure that our HVAC system, our heating and cooling system, is installed properly and it's properly designed, as well as the installation of the ductwork is installed without leaks. Yeah. So first of all, let's talk about the duct blast test. As we talked about earlier, that homes can easily leak 10 to 25% of the energy of the ductwork out through leaks in the system. And so this test tells us basically how much leakage we have, right?
That's correct. What we do is we'll depressurize the ductwork to a fixed level, and then we'll measure the airflow through the fan, and that pressure drop across the fan tells us what the leakage is.
We'll also be learning about the water management checklist, which is a checklist that helps us build homes that are free from leaks and therefore moisture-related problems like mold. We'll also be learning what it means to build a conditioned attic, where we have our insulation spray applied to the bottom of the roof deck, which makes our attic a lot cooler and our HVAC equipment much more efficient. And so what we don't want to happen in a typical home is for that heated air in our attic to be sucked into our HVAC system. But in a non-vented or conditioned attic system like this, the whole system stays a lot cooler, your system is a lot more efficient, and your cooling bills are going to be a lot lower. One of the biggest contributors to your cooling bill is heat gain from the attic. All day long, the sun bakes down on your roof. That gets absorbed into the roofing materials, and the heat gets absorbed into framing components, and eventually that heat gets re-radiated into the attic, and attics can get upwards of 120 to 150 degrees. And that's problematic for a few reasons. Number one, our ductwork, like in every home, is up in the attic. And the ductwork typically only has a couple of inches of insulation on it. So that means that 120 to 150 degree heat is being conducted to that ductwork, being absorbed into the air flowing through the HVAC system, which substantially heats up that air, which makes it more expensive for you to heat and cool your home. So what's the solution? Well, the solution is to do, like we have here, what we call a conditioned attic or a non-vented attic. Traditional attics typically are ventilated. This is a non-ventilated attic, and the way that this works is that they spray foam the entire inside of the roof deck. And what that does then, that creates the thermal envelope at the top of the roof deck, so that heat from the sun does not re-radiate into the attic, heating up the attic. So we basically take the insulation that was on the attic floor and we move it up to the roof deck. Except in this case, we use spray foam because spray foam is a better insulator and a better air sealer. Example is here. Outdoors, the temperature is about 95 degrees. In this attic right now, it's about 78 degrees. And here we see the chocolate bunny. It's not melting, and this attic is perfectly comfortable, being as comfortable as the house. Where typically these attics will only be about 3 to 5 degrees warmer than the house is. Now, another thing that's important to recognize is that most homes have lots of duct leakage. Anywhere between 10 and 25% of the system's efficiency is lost through leaks in the ductwork. So for example, let's say we have the return air duct of our furnace, which is basically drawing air out of the inside of the house, going through the system and being cooled by the system. Well, here we have a smoke generator, and we're going to show you what happens when all that hot heated air from the attic gets sucked into the system. You can see how easy that is. You know, these systems have quite a bit of pressure difference across them. And so what we don't want to happen in a typical home is for that heated air in our attic to be sucked into our HVAC system. But in a non-vented or conditioned attic system like this, the whole system stays a lot cooler, your system is a lot more efficient, and your cooling bills are going to be a lot lower. A critical component to high-performance homes is using the Energy Star checklist to make sure that we design and build the house according to the Energy Star protocols. Now, the Energy Star program has 3 basic checklists. They have the thermal bypass checklist, they have the HVAC checklist, and the water management checklist. I'm here with Michael Donahue from Jacksonville Building Science, and you're the one that actually goes out and tests and certifies these homes.
We certainly do. What's really exciting about this is that Providence goes above and beyond. They'll stop construction of the house while we do the inspection, and they will not proceed until everything has passed the inspection.
So let's talk about the thermal bypass checklist.
Okay. Well, one of the most critical components of the checklist is to make sure that the insulation is installed properly. This cavity here between the 2x6 framing has to be completely filled with insulation. There can't be any voids or crevices because that'll cause convection.
Right. And also, if the insulation is compressed, what makes an insulator insulated is the ability to trap air. So if you compress it, you can't trap the air. In fact, insulation that's poorly installed is about 30% less efficient than insulation that's properly installed.
Typically, in a code-built home, the insulation will be pushed into the wall cavity like this, and they won't bother to separate it around the wiring or the plumbing. And it's really important that you do that because you will create those voids.
And part of this thermal bypass checklist inspection is they make sure the insulation is not only installed right, but also that all the gaps and cracks and holes that cause air to leak in are going to be sealed up. So these homes are tight enough to prevent unnecessary air infiltration that costs you, the consumer, money. Yeah, so when we think about advanced framing, like here, for example, instead of seeing studs at 16 inches on center, they're actually at 24 inches on center, which allows us to get more insulation. In addition to that, they're also using 2x6 studs, which are deeper, which allows more insulation than standard 2x4s, which only have an R value of about 13. This has an R value of 20, so it's substantially more insulation as well. Providence Homes uses advanced framing techniques.
They certainly do, and that's the primary reason for doing it. They want to make the house more energy efficient. Obviously, with advanced framing, you can put more insulation in the house, so it's a good thing to do.
Now, the next checklist is the HVAC checklist, and that stands for heating, ventilating, and air conditioning system. In other words, every home has a furnace and an air conditioner and ductwork, and how that system is installed is really critical and designed to the overall performance of the home. So let's talk about the design of the system, because Providence Homes, they specifically engineer a system for every home that they build.
Energy Star requires that the installation of the HVAC system be inspected by the energy rater to make sure that there are no severe crimps or bends in the ductwork so that the airflow is as designed. Above and beyond all that, Steve, as the designer for Providence, as the mechanical designer for Providence, we also know exactly how much airflow is going to be required in every room. We know what size system is going to be, what size system is required because we did the load calculation. We did the specific, that house specific design.
Yeah, oftentimes builders just hand that over to an HVAC contractor and they engineer it as the best of their ability, but they're not mechanical engineers. So
that's absolutely true. And that makes Providence so unique. Nobody else that I know of actually has someone or has a mechanical engineer do their HVAC design.
And that makes sure that the ducts are going to be properly sized. Oftentimes in homes, ductwork is undersized. The HVAC equipment is grossly oversized. And so what you end up with is massive temperature swings, issues associated with efficiency, and certainly higher levels of humidity because the unit doesn't run long enough to dehumidify the air.
It also affects the homeowner's comfort because if the system isn't designed properly, it can be very noisy. And as we all know, we don't want to hear unnecessary noise. So Providence has theirs designed specifically for the house. And so when the system is running, you don't hear it. It's very quiet.
And also, part of that checklist is making sure that the ductwork is adequately sealed. Typically in homes, we see duct leakage upwards of 10 to 25%. That means that roughly 25 cents out of every dollar you spend on heating and cooling is being lost through leaks in the ductwork. That also lets in lots of dust, too. So the last checklist is the water management checklist. The last thing we want to do is build a home that has leaks, and ultimately that can lead to water moisture problems as well as mold related issues. So let's go out to a house and actually look at some of the things that are on this water management checklist. An important component of every Energy Star certified home is the water management checklist. An important component of that is the weather resistive barrier. Now, what the weather resistive barrier does is that it prevents water that gets in behind the cladding from being in contact with building components like the structural sheathing and the wall framing. And what's unique about a Providence home is that they use Tyvek, which is a breathable weather resistive barrier. A lot of builders use cheaper perforated building wraps, which are nothing more than just plastic with holes punched in it. So another important part of the homes that they build is the window flashing system. And this window flashing system is what we call pan flashing. It's a one-piece, moldable piece of flashing that goes around the entire window component so that if water does get in behind the window, it has the capacity to drain and get out, and it protects those components from water and moisture damage. One of the most impressive features about a Providence home is the battery of tests they do on each and every home that they build. With me today is Michael O'Donohue from Jacksonville Building Science, and you're the actual guy that your team comes out here and actually tests every home.
Yes, we do.
Let's talk about some of the tests that you do.
Well, typically Providence will reach out to us about a week or so before closing and ask us to come out and do the Energy Star testing. So we come out and we'll do the blower door test, we'll do the duct blaster test, and then we also go above and beyond that by doing a test and balance, which really isn't required by Energy Star, but it's the right thing to do. It adjusts the airflow in all the rooms to make sure.
It's important to note that what makes an Energy Star builder a certified builder is they build 100% of their homes that are all Energy Star, which includes not only the checklist we talked about earlier, but also this whole battery of tests that can take anywhere from a half a day to a day.
That's correct. Yeah.
So first of all, let's talk about the duct blast test. As we talked about earlier, that homes can easily leak 10 to 25% of the energy of the ductwork out through leaks in the system. And so this test tells us basically how much leakage we have, right?
That's correct. What we do is we'll depressurize the ductwork to a fixed level, and then we'll measure the airflow through the fan, and that pressure drop across the fan tells us what the leakage is.
Yeah, so the number on that fan is the actual amount of leakage.
That's correct.
And what do you shoot for?
Typically in a Providence home, the total test is around 4.5%, so well below the Energy Star standard. And the outside test is very low because it's a foamatic and there really isn't very much to the outside. So anywhere between 0 and 1% for the outside test.
Yeah, so bottom line is this house has very little duct leakage.
These ducts don't leak.
Now, it's really important when you're designing HVAC systems that you deliver the right amount of air to the room. So these systems are highly engineered to make sure that you achieve the comfort you have. So if you have leaks or kinks in your ductwork, you wouldn't know it unless you do the proper testing.
That's correct. One of the unique features of a Providence home is that we do airflow testing above and beyond the Energy Star test. The airflow test allows us to measure the air coming out of all the grills in each room, and we can compare that against what the load calculation calls for and then make whatever adjustments are required.
Yeah, so the basic idea is you engineer these rooms to have a certain amount of airflow. This is the test that determines if you got the right amount of airflow.
Exactly. And what we typically do is we'll just take this analysis flow hood, put it up to the grill, push the button, and wait 22 seconds while the sensor captures the airflow, the pressure, and the humidity and transmits it to the computer, which then does the analysis for us.
So what that's doing is actually measuring the airflow that's going to be coming out of that duct.
That's correct. Yeah. Once we're done, once we've captured the airflow out of all the ducts and tabulated it on the computer, then we can then compare it against what the load calc calls for and go back and make all the necessary adjustments so that the air in every room falls within the tolerance of the load calculation.
And so the next test and final test that we're going to talk about today is a blower door test. And this is where we actually measure the air tightness of the home. And the goal is to have a tighter house rather than a leaky house because, again, you don't want to pay to heat and cool the outdoors. So tell us about the tests you typically do on a Providence home.
We draw the air out of the house, and the airflow, again, across the fan, the airflow tells us exactly how leaky the house is. And like you say, we want the air changes per hour to be as low as possible. Because this is a Providence home, the standard or the limit that we accept is 2 air changes per hour of 2. And typically the Providence home is somewhere in the neighborhood of around 1.5, occasionally as low as 0.5.
And one of the advantages of the conditioned attic, the spray foamed attic, is you don't get near as much dust in the home, and also you don't get a lot of moisture in through the attic ventilation system as well.
That's correct, yes. These houses are very tight. They're very dry, and the homeowners are very comfortable.
And it's important to recognize that the beauty of this testing is that it helps all the subcontractors know that their work is going to be evaluated and measured on every home. And some builders will only test a couple of houses out of all that they build. In this particular subdivision, for example, they test each and every one. And you don't know unless you measure, and you can't improve unless you test.
That's correct. There has to be oversight. Otherwise, you just don't know what you have. And we test every Providence home. And if there is a failure, and occasionally there is one, the contractor comes out, makes the repair, we come in behind them and test again to make sure it's a pass.
So the key to a high performance home is really designing energy efficiency in, making sure that your crews follow all these checklists, and making sure that you evaluate and test each and every home to make sure they perform in the real world like they do on the drawing board.
Absolutely.
To learn more about the benefits of building an energy efficient Providence home, visit myprovidencehome.com. Providence Homes, your hometown builder.
An important component to every energy efficient home is what we call a non-vented attic or a conditioned attic. Typically in homes, what we do is we simply insulate the lid or the ceiling, and what happens is that the attic in the summer times get upwards of 120 to 150 degrees. The sun bakes down all day, heats up your roofing system, and re-radiates that heat inside your home. The problem with that is most of our heating and cooling system is up in the attic. And so the air inside of our heating and cooling system in the summer months is typically going to be 55 to 60 degrees. But if our attic is at 120 to 150 degrees, that re-radiates that heat and creates thousands of BTUs of additional cooling required. So what we do to fix that is we basically take the insulation that was on the attic ceiling and we simply move that to the bottom of the roof deck. That prevents that energy from the sun from being re-radiated into this attic space. So your attic is typically within 5 degrees of your conditioned space. So that means that your HVAC system is going to run a lot less, you're going to be a lot more comfortable, and you're going to have lower energy bills. Now another real benefit to this is indoor air quality, because what we do is we seal this attic. A traditional attic, we have ventilation running through it, brings in lots of dust and dirt. So one of the advantages of air sealing this attic, we'd have very almost a dust-free environment inside the home. And of course, dust is a key allergen, and so we want to make sure that we air seal this attic, and it gives us a lot better indoor air quality inside the home. Health and wellness is a really important part of every new home, and a critical component of that is good indoor air quality. And good indoor air quality really starts with making sure that the home is certified to EPA standards, and that program is basically the Indoor Air Quality Plus program. Now, we spend about 90% of our time indoors. We breathe about 3,000 gallons of air every day. Indoor air can be 2 to 5 times more polluted than the outdoor air, according to the Environmental Protection Agency. So what this certification does, they make sure that the home is watertight, that we don't have leaks that can lead to mold and mildew. They have inspections and checklists for that. They make sure the home is designed to be more pest-free, so we don't have lots of insects. We make sure that the ductwork is sealed so that we don't have a lot of air leakage bringing in contaminants. We make sure that during construction the ducts are covered and protected so that we don't get a lot of debris inside the ductwork. We make sure that we use low VOC paints and building materials, because volatile organic compounds can lead to a variety of indoor air quality problems. And so it's really important that when you're looking for a home that you make sure it has this EPA Indoor Air Quality Plus certification, and that builds on the Energy Star Homes program. So when you're looking for a builder, you want to make sure that they're Energy Star rated, and that you make sure that they're certified, as well as have the Indoor Air Quality Plus certification. You may have heard the term zero energy home. What that means is a home that produces as much energy as it uses. Now, what Providence Homes offers in a few of its communities is what they call zero energy ready homes. What does that mean? Well, the goal is to make the home as energy efficient as possible so you don't have to add a lot of expensive solar panels down the road. So each one of these homes are number one, Energy Star rated. So that means that they do ductless testing, they do blower door testing to make sure the home is energy efficient, and a whole checklist of things that make the home really thermally efficient. Another key component, it's Indoor Air Quality Plus, which means it's healthy and safe to live in. These are all Department of Energy programs that are very rigorous standards that only a few builders in the United States build to. So essentially what they're doing is they're future-proofing your house. So they're building it extremely energy efficient, so you can add solar later if that's what you choose to do.